All right, guys, let me ask you something. How is it that my Tesla can drive itself around town without LiDAR, without radar, and just using cameras? Like, seriously, no spinning roof sensor, no crazy stack, just cameras and software. Today, I want to break down how Tesla's full self-driving actually works, based on Tesla's own patents. Not speculation, not hype, actual documentation. And once you understand this, it kind of changes how you see FSD. In this video, I'm going to break down this into three simple parts. First, how Tesla turns camera footage into a 3D world. Second, how it predicts what's going to happen next. And third, how it figures out depth without LiDAR, because that's the part everyone argues about. Honestly, once I read through the material, it made way more sense how Tesla is approaching the entire problem. Now, before we go any further, let's quickly define a few terms because these get thrown around a lot. First, LiDAR. LiDAR stands for light detection and ranging. It works by shooting out tiny pulses of laser light and measuring how long they take to bounce back. That time measurement tells the system exactly how far away an object is. So instead of seeing with cameras, LiDAR creates a super detailed 3D point cloud using laser reflections. That's why cars with LiDAR usually have that spinning sensor on top, like a Waymo. It's constantly firing laser pulses and mapping out the 3D environment. It's extremely precise, but it's also expensive and hardware heavy. Okay, so second, let's talk about radar. Radar stands for radio detection and ranging. Instead of lasers, it uses radio waves. The car sends out radio signals, and when they bounce off objects, it measures how long it takes them to return. Radar is really good at detecting distance, speed, and movement. It works especially well in bad weather like rain, fog, or snow, but radar doesn't give you a detailed image. It tells you something is there and how fast it's moving, but not necessarily what it is. Tesla made a very bold move when they decided to go vision only. No LiDAR, no radar. So they removed radar, which a lot of people thought was crazy. But here's the logic. Humans drive using vision. 2 eyes and a brain. That's it. So Tesla's thinking is, if you can build a neural network that understands vision better than a human, you don't need LiDAR. You don't need radar. Every Tesla has cameras all around it, in the front, on the sides, and in the rear. And all of those things feed into the neural network. But here's the key part. The system isn't looking at each camera separately. It combines them together. It stitches them together. It builds one unified understanding of the environment around the car, and that's the foundation of everything else that FSD does. Now, this is where it gets really interesting. The patents describe something similar to virtual cameras. Basically, Tesla takes that 2D image from all those cameras and reconstructs a 3D spatial model of the world. Think of it like the real world being turned into a live video game map. The system builds a bird's eye view representation and tracks objects in 3D space. Cars, pedestrians, cyclists, dogs, lane lines, curbs, and drivable space. All of it is mapped and updated constantly. As the vehicle moves, it gains depth information from motion, just like your brain does when you move your head. That motion is incredibly important because it unlocks the ability to understand space and position in a much more advanced way. So here's something most people don't realize. FSD doesn't just see a single frame, it sees time, it builds what's called a time series, and meaning it tracks objects across multiple frames over time. So if a pedestrian walks behind a truck and temporarily disappears from view, the system doesn't just assume they're gone, it actually starts to predict where they should reappear. The same goes for cars and cyclists and even lane lines. If something is briefly blocked or partially obscured, the system continues to model it. That's huge. Driving isn't about reacting to what just happened. It's about anticipating what's going to happen next. The predictive element is one of the most important pieces of Tesla's approach. Now, let's talk about the controversial part, depth. How does Tesla measure depth using only cameras? Well, according to the patents, Tesla processes certain areas of the image at higher resolution, so big resolution, and the rest at lower resolution. Similar to how humans' visions work. You focus sharply on what matters, and your brain fills the rest. The approach that they take makes the system more computationally efficient. And because the car is moving, it gets depth information from motion. Things like parallax and perspective shift from frame to frame. So again, before we go any further, let's quickly define a couple of terms that I had to even learn myself. So first, let's talk about parallax. This is something you probably experience every day. If you hold your finger in front of you and you close one eye, then you switch eyes, well, your finger appears to shift position. That shift is parallax. And it's the difference between how objects appear when viewed from slightly different angles. Your brain uses parallax to calculate depth. Tesla uses a similar concept. So as the car moves forward, objects shift in position relative to each other in the camera view. That motion helps the neural network estimate how far away things are. So instead of using lasers, Tesla uses motion and perspective changes to understand depth. Next, let's talk about perception. In the context of self-driving cars, perception means the car's ability to understand what it's looking at. Not just detecting shapes, but recognizing that that's a pedestrian, or that's a stop sign, or that's a drivable road, or that's a parked car. Perception is basically the seeing and understanding stage. So before the car can decide what to do, it has to understand what's around it. That understanding is perception. So on top of that, Tesla has millions of vehicles collecting real-world driving data. That massive data set allows the neural network to learn depth and velocity directly from video at scale. That's the bet Tesla is making. That scale and data can outperform expensive sensor hardware. So what does it all mean? Well, Tesla isn't building a sensor-heavy robot car. They're building an AI perception engine. It creates a live 3D map in real time. It tracks objects over time. It predicts movement and makes decisions based on probability, and it's scalable. It improves with fleet learning, but it's not perfect. Let's get it right. It's just not perfect. Prediction is difficult, and edge cases still exist. So weather, lightning, and unusual situations can all create challenges. But once you understand how the system is designed, you start to see why Tesla believes vision alone can eventually solve autonomy. Whether you believe it or not, they believe this. Now, whether you love FSD or you're just skeptical about it, understanding how it works changes the conversation. This isn't magic. It's computer vision, neural networks, and massive real-world data. So, trying to get to our 100 subscribers. So if you enjoyed this breakdown, comment on your thoughts, hit the like button, and please subscribe if you want to see more videos like this. My name is Patrick, and I live in the Quad Cities. And if you are new to my channel, well, welcome to my channel. And if you are a returning viewer, thanks for coming back. And if you are looking to buy a Tesla, feel free to use my referral code in the description or visit my website, qcteslaguide.com, to save money on your purchase of a Tesla vehicle. So, all right, guys, as I always say, use technology to drive safe so that you can live life. And thanks again for watching, and I'll catch you in the next one.